Commercial horticulture production offers one of the highest quality food production there is, but there is a few drawbacks with it. First is that it uses a lot of water, and water is getting scarce, high quality water, especially even in places like UK and Netherlands that have a lot of rain, and they're getting even more scarce in other countries in the southern Europe. And the second problem is that it uses a lot of fertilizer. A lot of synthetic fertilizer that when used in excess can leach into the waterways and then pollute the waterways, pollute the sea and cause toxic algal blooms that can impact the sea food chain and our own fish stocks that we depend on. So in Bio4safe project we try to tackle that by demonstrating different ways we can reduce water use and reduce fertilizer use in horticulture. So we are several institutes from around the two seas region, so around the Channel Sea and the North Sea. We have two institutes, University of Ghent and Ornamental Institute from Belgium. We have North Sea Farmers and Vertify from Netherlands. It's us in the UK, NIAB EMR, and then we have two Unia from Lille and Pôle Légumes. They're both French institutes that we're working together to pool the resources and demonstrate on the widest possible scale the benefits of two main methods that we're trying to use. First is use biostimulants, and second is use irrigation tools to better monitor and better apply irrigation. We are funded by European Two Seas Interreg project to achieve better water use and achieve better fertilizer use. We had four main objectives. First was to demonstrate in commercial setup the use of biostimulants and the use of precision irrigation in variety of different crops. So in the UK we used raspberries and strawberries, in the Netherlands they used tulips and winter wheat, in the Belgium they used ornamentals, and in France they used tomatoes, lettuce, cauliflower, etc. So we're covering a large array of crops. The second objective is to produce a free database on biostimulants to get the word out there which biostimulants work on which crop and which don't. Third objective was to provide leaflets and protocols for growers to follow on how to use different sensors and how to use precision irrigation to reduce their water and fertilizer. And the last objective is to trial a seaweed farms and make seaweed biostimulants from the harvested seaweed. On our Bio4safe website, www.bio4safe.eu, you can find information about different sensors that we use and how different sensors can be used by growers to improve their water and fertilizer efficiencies. The next thing we have trial protocols, so how to grow using different sensors and cutoffs to use for irrigation, what to pay attention on when you're measuring different things to maybe be able to incorporate sensors within your growing crops. And the biggest thing is that we have is the biostimulant database, where you find several hundred entries at the moment about biostimulants and their use in different crops. In terms of demonstration trials, we did three consecutive years of trials. We did trials on long cane raspberry and June bearing strawberry. We had commercial size plots. We had commercial fertilizer scheme, commercial substrates, coconut coir substrates, and we had precision irrigation installed in all trials. What we tried to achieve is demonstrate that our 5 different biostimulants that we're testing reduce water and fertilizer, and demonstrate separately that just precision irrigation on its own can already do that. We have been using several different tools to monitor the plant yield and performance. We measured quality and quantity of fruit. We measured the sugar content of the fruit. We then measured photosynthetic parameters of the leaves at different times, with and without stress, and we try to tease out the biostimulant effect by using different amounts of stress. So we reduced water by 20%, 40%, and then applied some short-term, even more stressful event when we just switched irrigation off overnight. We had not seen any positive or negative effects of the biostimulant in our trials, but what we have seen, and it's a significant finding for us, is that when you drive your irrigation based on plants' needs, so you only give amount of water and fertilizer that they need based on our sensors, reporting back sugaring irrigation, we could save up to 60% of runoff and up to 40% of the inputs in strawberry, and about half of that in the raspberry, without any detrimental effects to yield or quality. So the take-home message is that there's a lot of room for improvement in terms of irrigation scheduling based on the plant's needs, and lots of water and fertilizer can be reduced that way.
So here we are at the Water Efficient Technologies Centre at NIAB EMR, and we're standing here next to one of our raspberry crops. So we all know that plants need an optimum supply of water and fertilisers in order to deliver the high quality flavoursome berries that we all enjoy. And I think we also know that underwatering a plant can reduce yields and berry quality, but perhaps less well recognised is the fact that overwatering plants can also reduce yields, reduce flavour, and also limit shelf life. And most growers will tell you that raspberries don't like wet feet, which means that they don't like to be sitting in with a very wet root system, because we know that can impact on yields and quality. Matching demand with supply is important, but especially challenging is this transition from hot sunny days to cool cloudy weather. And the tendency here then is for growers to apply lots of water in the hot sunny days and don't necessarily reduce those inputs during the cool cloudy weather. And as I said before, those water use by the crop can be reduced by 13-fold in such conditions. So it's very important that we're able to match demand with supply and give the plant exactly what it needs. And so what we've been developing at East Marling over the last sort of 10 to 15 years is a precision irrigation system. It's an on-demand system, which means it's fully automated. And essentially what the system does, it accounts for those very different water loss, rates of water loss during this very changeable weather, and it matches demand with supply in those very warm sunny days, but also on those cooler cloudy days as well. So the precision irrigation system that we've developed here at East Marling is a sensor-based system. So this is a Delta T Devices SM150T sensor, and essentially this sensor measures the water content in the coir surrounding the root systems of the plants, the raspberries in this case. And so ordinarily then we would insert this sensor into the root system, and so this would then read the volumetric moisture content of the coir every 10 or 15 minutes, and so we get almost real-time information on the water content then in the rooting system. And this system then is hardwired into a data logger, in this case a GP2, and this then logs the information from the sensors. And so the idea is then that we identify a set point, an irrigation set point. That means for this particular variety, the moisture content in the coir is optimized. So we're not too dry and we're not too wet. And so when these sensors then are sensing the decline in moisture content, once that set point is reached, the values are all averaged. Once that set point is reached, then this system will trigger the irrigation rig automatically, and the irrigation rig will deliver a sort of a defined volume of water and fertilizers. So using these sorts of technologies then we can make sure we optimize irrigation and also the addition of fertilizers, and of course that helps to minimize any transient stresses that we know can impact on yield. But of course it also helps to optimise water use efficiency, also helps to reduce emissions to land, to air and to water, and of course it also helps to ensure that we get a high yield of phytonutritious and flavoursome berries with good shelf life potential.
One of the great features that comes with the precision irrigation package is a near real-time online report. This connects to the various sensors that are deployed as part of the PIP and allows the grower to monitor what's going on in their crop even when they're remote from site on any internet connected device, whether that's a laptop, tablet or indeed their phone. So for example, on this version here we've got soil moisture, coir, electrical conductivity as an indicator of fertilizer level. We've got the percentage runoff, so we can control within quite tight parameters the amount of water that's being used.
So we are at the Clockhouse farm talking to irrigation specialist Ollie Becker, and we're going to discuss a bit more how precision irrigation can be used on the real farm, not just in research. So first, Ollie, what kind of crops you're growing and how large is your farm, and any details if you can give us?
At Clockhouse Farm we're growing 150 hectares of soft fruit and 100 hectares of top fruit. And soft fruit is blackberries, raspberries, strawberries and apples and plums.
Before you put any sensors in precision irrigation, you were running on timers.
Yes, we've been using timers, and we've also been using Ransom on the irrigation rigs, and move away a few years, must be about 5 years now, what we move away onto precision irrigation. Most of the farm has been covered with precision irrigation. We will, going in the next few years, the whole farm will get covered in precision irrigation. We first trialed it in soft fruit and moved it over into the top fruit, and we are getting pretty good results, top fruit and soft fruit wise.
Was there any problem switching from timers to precision irrigation, or is it a smooth transition, or how did you?
It was pretty smooth. The only thing was, typical human don't like changes too much, but when the staff got their heads around it, they've been kind of like it on the moment. They're just pushing, they want more systems. It makes it for them so much easier to monitor where they are, and we are quite multi-sited farm, and the guys can see what's going on other sites. I can log in and see what is happening on the rest of the farm. When we planned how many sensors, it all depends on the layout of the site, the field we're standing in. As you would see, there's a bit of a slope. This specific field is split in a few irrigation valves. We'll have sensors at the top end and also sensors at the bottom end, and that is just on climate and the water what the plants will need. But if we go to a more flat area, we can do with one sensor quite a few hectares.
Okay, that's very good. What would you say were the main benefits that you see on the farm from the precision irrigation?
We grow a better crop. Our plants is a lot healthier. We get a better root system, and what that would mean is we do get bigger yields, and plants is healthier, and we do get fertilizer and water usage savage. And with the Environment Agency force us with trickle water licenses, what they're going to implement, we need to save water, because it's not like the old days where we can abstract as much as we want. So we need to save water, and with water what we can save, we can expand as a business, we can expand more hectare-wise.
You see any difference in labor or in post-harvest quality or anything like that?
Labor, it is less. We can get away with less people, with less checking rows, because we got more even irrigation systems, and it's more remotely what they can lock in and see what's going on. Quality of fruit is better, and yeah, we are pretty happy.
Okay, very good. Thank you.